Tonight's video is on section 3.6, solving decimal equations. And we start with this first problem where it says four people are sharing a restaurant bill of $58.25. So we want to split that evenly. So we take 4 times each person's contribution, and that's going to equal the total bill. So in order to solve for x, we have to divide both sides by 4. When we do that, we get 14.5625. But if we're talking about money, we want to round that to $14.56. So then we go through the check and we plug in 14.56 and we don't get two equal sides. We get 58.24, $58.24 equals $58.25. That's really close, but they're not exactly equal. Well, why aren't these equal? So I want you to think about that question and why might those two sides not be equal? The answer is indeed $14.56, so they should be. So I want you to write down just in the margin there why you think that they're not equal. And we'll talk about that in class. Then question number 2 here says 26x minus 32 equals 99. So we add 32 to both sides, divide by 26, and we get 5.038461538, so on and so on and so forth. And we're going to round that answer because we don't necessarily want all of those decimals. After the hundredths place, it's a very, very, very small amount, so we really don't need those there. And this would be, if you didn't want to leave your answer as an improper fraction. Leaving it as 131 over 26 is a better answer because it is exact, but rounding it is very close. Okay? So then this next problem is a very lengthy and detailed problem, and it has a whole lot of decimals in it. And decimals can be solved that way, but it can also be solved by multiplying everything by 100. And let's see if I can sneak that in the picture there. So we can multiply the entire equation, both the left side and the right side, by 100. And we know that when we multiplied the two sides of an equation by the same thing, it still remains equal. And so by multiplying by 100, you'll notice in the second line, it got rid of all my decimals. It essentially moved the decimal point over 2 places to the right on each of those numbers. Now I can solve it and I don't have to worry about decimals because it's just whole numbers. And then when we get our answer, we get x equals 0.70. Now, the question always comes up, do I have to multiply that answer by 100 or do I have to divide that answer by 100? And that answer is no. You do not have to do anything once you solve for x because you kept the equation exactly the same when you multiplied by 100 on both sides. So you don't have to do anything with the answer. And in fact, if you went through and solved that equation without multiplying by 100 first, so you left the decimals as they were, you would still get the answer of x equals 0.70. All right, couple more problems. Problem number 4, if we have this decimal, what should we multiply by? Well, if we multiply by 10, that's going to move the decimal point 1 place to the right, which would be fine for the 5.2x as well as the negative 8.5x, but that's not going to be enough for the 15.78 or the 9.45. So by multiplying by 10, it does a little bit of something for us, but it doesn't really get rid of all the decimals. So instead of multiplying by 10, we're going to multiply by 100. That means everything gets multiplied by 100. So we're going to have 945 minus 520 because that decimal point goes 2 places to the right. So it would be 520x equals negative 850x. Again, move that decimal place 2 places to the right, plus 1578, 1,578. So now that we've talked about what to multiply by, go ahead and solve that problem for tomorrow. And then question number 5 says you're shopping for a necklace. The sales tax is 6%. You have a total of $21.25 to spend. What's the price limit for the necklace? So you notice here I wrote a verbal model and we studied that just a little bit earlier in this chapter. So the total price is going to equal the price of the necklace times the sales tax amount, and that is going to give us the price or how much we're paying for sales tax plus the price of the necklace that we have to pay for. So then our total is $21.25. The price of the necklace we're going to say is X, and then the sales tax is 6%. So this is a real life application of solving equations with decimals. And so we substitute in our algebraic model, we put in our variables and our numbers, and we solve. And we find out that it's $20 and 0.471698 cents. So we have to be really careful here because normally we would round that up to $20.05. But if we round that up to $20.05, will we have enough money or will we be a penny over? So you need to check. And so that's why I say down here, rounded answer. What would that be? Do we want to round up? Will we have enough money in this situation? Or are we going to round down? All right, the last thing I want you to do for tonight, it says that you're shopping for a new bike. The sales tax is 5.5%, and you have a total of $100 to spend. What's your price limit for the bike? So please do what I did with the necklace problem. Write your verbal model, then substitute in your labels, and then lastly, write the algebraic model and solve. That's what I'd like you to have for tomorrow. Have a good night.